Well, I have the honor and pleasure today of being a producer. I really am thrilled to welcome Andy, the director of Improving at Minnesota, today's talk. Andy brings over a decade of DevOps and platform experience, working with organizations ranging from startups to Fortune 500 companies. With a deep passion for infrastructure as code and platform automation, Andy has been using terraforming since its early days. He did provide the version number. I'm so sorry, everybody. I'm not familiar with the version number, but I would encourage you to ask him. It starts with a zero, though. Now, Andy is based out of Minneapolis, and he lives with his wife, two kids, a cat, and a dog. So he has no cat or dog alliances, neutral territory here. So when he's not helping organizations streamline their operations, you'll find him bowling, producing music, working on his latest woodworking project. Now, for today, Andy is going to have the pleasure of speaking to us on platform engineering excellence, streamlining cloud data and app integration. And just a reminder for all of those joining, this is part of our Tomorrow Technology Today series. So while we get to hear about Andy's expertise, join us the entire month of October on Tuesdays to learn more about what we have in store. Now, without further ado, Andy, I'm going to turn it over to you because I know you are the star of the show and what everyone came to see. So thank you so much and take it away.
Sure. Thank you, Emily. Thank you for joining today's webinar on platform engineering excellence. As Emily said, I've been working in the platform space for the last 10 plus years, and I've built a number of these enterprise scale platforms from the ground up. I've spent a lot of that time in highly regulated environments like finance and healthcare, and I've seen all of the different benefits that a strong platform can provide. So we'll get right into it. So today I want to spend time talking about what platform engineering is and how we can use the principles and best practices to drive a better developer experience. Really what we're trying to do when we're building out these great platforms is to empower development teams to spend less of their cognitive load thinking about all the pieces that go into delivering software and let them focus on driving features and business outcomes. So we're trying to abstract away all the tedium of infrastructure, security, observability, and give them a way to scale while remaining quite flexible. So what is platform engineering? In today's talk, I'm going to walk through what I see as the solid sort of foundation of the platform experience and some examples of how we approach those different problem sets. So platform is all about providing a flexible experience that allows us to get code from a developer's laptop into production with as little friction and overhead standing in their way. They should be able to be empowered to follow sort of that DevOps mindset and provision any resources they might need in a straightforward way, while again, not having to take into account all those other variables that might be surrounding that process. So a metaphor I've been using a lot lately is this idea of a bridge that goes across a large span. And we need structural supports to hold up that bridge, and the bridge becomes our platform. So these are a few of the pillars that I see when I'm working with clients that are more or less requirements to building out a successful platform, especially at scale. And the reason I like this bridge metaphor is that if any one of these pillars is starting to erode in quality or showing its age, we need to build it back up or we risk the rest of the entire platform collapsing. So we need this foundation to be strong if we're going to provide a way for teams to be productive. So the first and maybe most important or obvious pillar is version control. We need a way to track changes to our code, let our development teams collaborate, and provide governance around how that code is developed. There's a lot to unpack here around branching strategy, how repositories are structured, and so much more around version control. But at this point, most organizations have some sort of process in place for this. I'm going to try and hold my promise that I won't spend a ton of time on version control, but this is really the first entry point and how most developers will actually experience the platform from the start. So the next pillar is what we do with that code once it's been committed and the changes have been pushed and we're ready to see what's next. This is where we talk about continuous integration, continuous delivery or deployment, CI/CD. This is also sometimes just referred to as pipelining. And we're building pipelines to follow a set of steps from one end of the other in a predictable way. Just like water flowing through a pipeline, it has one direction it can go, regardless of where the bends and curves might be. And our code follows this pipeline through predefined channels and steps in a very predictable manner. So the next pillar is not necessarily a requirement, as plenty of customers are operating successfully in the data center, but one that I think provides a ton of value is public cloud. So utilizing public cloud can provide much faster iteration on technology and, providing a way to physically scale your infrastructure in near real time as opposed to waiting for hardware. And the cloud comes with a whole host of other benefits that we'll dig into further. But I would also call out that this could be the greatest weakness in plenty of platforms. It could be due to cloud cost ballooning, mismanagement of security concerns, or even just the added complexity of using the cloud causing delays in troubleshooting or understanding where the issues might be. So to address some of that, the next is infrastructure as code. This is, as Emily said, one of the things I'm most passionate about. And the concept behind infrastructure as code is to provide a way to consistently build and deploy our environments where our application code or our data platform is going to live. This platform and this practice allows us to apply the same software development lifecycle concepts to the rest of our underlying environment that's actually running our applications or our code. That includes the previous pillars of version control and CI/CD, and using the proven practices that provide high quality code around version control and CI/CD, we can iterate quickly on our infrastructure and apply that infrastructure where we can be proactive rather than reactionary. We can enforce policy and governance through this code. And this is especially important, like I said, in those highly regulated environments. So the next pillar is observability. Observability covers all of the concepts of monitoring our applications or data sets and making sure we know things are operating as they're supposed to be. This allows for a tight feedback loop to development teams on how their code is performing. And it allows infrastructure and operations teams to monitor and be alerted when something inevitably goes wrong. We don't want to see an outage, but this is what prevents us from crossing over into that. The last pillar, excuse me, the last pillar is really tying everything else together that came before it. So this doesn't mean it should be the last to be implemented, but it is sort of the culmination of everything else into what many organizations consider the platform, and that's self-service. This is also really where the developer experience is showing itself. The idea behind self-service is that if I'm a developer or a data analyst or someone onboarding to an org, I don't necessarily need to know about all the other pillars. I have a developer portal or some other development platform where I can quickly get something up and running. This could be driven by committing some declarative code to a repository. It could be through a ticketing system, or it could be, like I said, a portal of some sort where there's essentially a marketplace of actions or services that I need as part of my day-to-day work on a development team. So this is where I like this metaphor of looking at it from the development point of view. If this means if I'm a developer, again, a data analyst, a development team, whomever, this should be what they see. A very obvious path forward. There's no stoplights, there's no crazy twists and turns to navigate. There's a straight path to where they're trying to get to, and that is production. And along the way, you'll notice the guardrails. And these are the feature of the foundation and pillars that we've built to support the platform. Teams are not suddenly going to be able to make a mistake and drive off the road. We've paved a way for them to get from one side to the other on their own, and they don't need to think about all those other things that are making that possible. So now that I've laid out sort of the high-level concepts of what these pillars are, I'd like to dive a little bit deeper into each of them. And I'm going to try to cover these concepts and provide some real-world examples of how these are each contributing value to the rest of the organization. So going back to our original pillar, we have version control. I've tried to promise that I won't spend a ton of time on this, mostly because I think most organizations have adopted some sort of version control. The vast majority of those are using Git. And the idea here is not how to use Git, but just to illustrate that having an efficient practice around version control provides some of the quickest returns on quality and speed with which teams can deliver value. So the three main benefits to a modern, mature version control strategy are code quality, governance, and release management. Providing a process by which organizations and to organize changes for features and bug fixes, we can increase that code quality very quickly. It means iterating quickly. It means getting a tighter feedback. We can deliver changes quickly. And the goal here is that we've provided a clear process to define how changes are being introduced. We then bring that governance aspect by putting rules in place of how those changes get pushed into the rest of the code base. This is usually done through enforcing peer review, as well as automated testing, passing, but we'll talk a little bit more about that when we dive into CI/CD. So our version control system allows us to manage how we release our code. When is it ready to go out into production? And the practice here is that we have multiple environments where we can work against the code base, but we know which code is released and where it's been released to. And this applies to the data and infrastructure pipelines as well. So leading into pipelines, we're going to talk more about CI/CD. And this is tightly coupled with the version control. As our version control system is what's going to trigger our pipelines, it could be a request to merge new changes into the code base. It could be the result of a merge or kicking off an entirely different pipeline as part of that release process. So the goal of our CI/CD system is to eliminate manual processes, tighten our feedback loop around changes. And if a developer pushes a new bug fix or a new feature, we want a way to automatically validate that those changes are not going to break any existing functionality. This reduces our risk around accepting new code changes and is what drives that speed in the version control, getting changes pushed out. So all of this depends on good testing frameworks being integrated into the code base, but it provides immediate benefits for that increased quality. It's also providing that speed because we don't need to have our development workflows depend and wait to see if something's been broken. Good integration and regression tests built into the build process let us know all of that right away. We can also use CI/CD to build the reliable and reusable artifacts that we know are consistent. Again, this is not new to most organizations, but I have seen too often at clients we go build it on so-and-so's laptop and we SSH it to the server to deploy it. Building that single artifact and moving it through our environments gives us confidence to say that we know what will happen and where. So this is mostly covering continuous integration. The continuous delivery or deployment piece happens immediately after our successful build, where all of our changes have been pushed through. And ideally, that means every accepted change is being deployed somewhere for the rest of the systems to interact with it. In the world of microservice architecture, this is especially important. We should have an environment that the rest of our services are running and we can test against. By deploying quickly, we reduce that human intervention or delay, and again, close that feedback loop back to the development team. The platform should be reducing the need for developers to understand how or where their application is running. And that platform team is essentially providing the service of understanding all of those underlying details of what it takes to run an application, what tools are being used to get it there, and what underlying technology is orchestrating their services or their applications. As a developer, it is definitely useful to know that my code is being containerized and gives me flexibility for running it locally, but I shouldn't have to learn all of Kubernetes or Helm or any other number of tools that get that container running out in the environment. I would say that most good developers do know and care about how this process is happening, but it shouldn't be a necessity to interact with the platform. Again, the goal is getting from their workstation to production, and how that takes place is part of those guardrails. In large organizations in particular, you could end up with 3 different teams doing things 3 different ways. If you're a new member of a team, chasing down the documentation of your team's particular implementation of deploying containers can be a huge barrier to just getting your code written and deployed. If instead that platform team and the platform is consistent, there's a single source of truth, and it doesn't matter if you're brand new or change work streams from team A to team B, you know that what that process is going to be. You hopefully trust that it works, And when it doesn't, you have one place to go back to understand why. This also empowers the scaling out of the organization and the services, because when a new product or application comes up, you already have a lot of that governance and development process built into the platform itself. You don't end up being the fourth team doing things a fourth way. The deployment automation is also key to that version control step of release management. We aren't just pushing code to our development environment or a test environment. Our goal is production. And we can greatly reduce the time that it takes to deploy that code by using our pipeline to promote all of those changes. I was at a client recently where they were running a SaaS application and deploying new releases like weekly. And when I joined the team, we were supporting about 10 customers, and each of our deployment evenings took around 3.5 hours to get those 10 customers on the latest build of the application. While they had great testing and pipelines to build artifacts, getting those artifacts promoted to production had a ton of manual intervention. They were rapidly acquiring more business, and it wasn't going to scale. So we started with some of the more basic tasks, and eventually we got the entire process automated, where we created pipeline jobs to allow us to click a single button, trigger all of our deployments in parallel. And because of that automation, this took our deployment time each week down to about 35 minutes to deploy to over 45 customers all at one time. So automating repetitive tasks is one of the best ways to gain that agility and consistency when using a good CI/CD pipeline. So I want to take a moment to pause. As Emily talked about, we have a great list of talks set up for our technology series here. And next Tuesday will be with Rich McGraw. And his focus there will be on modern data platforms and how to know if the way you're blending your systems, architecture, and governance are actually going to meet your data platform needs. So please tune back in next Tuesday for Rich's talk. So our next pillar here, we're going to dig into public cloud a little bit. Again, you could argue that this is not really part of the platform itself, as everything else in our platform could be happening in a data center or on-premise. However, I think there's some key differences about adopting public cloud as sort of an essential part of the platform. I think the biggest upside to public cloud is really just flexibility. You're able to scale quickly and dynamically adjust your resources. You aren't purchasing and maintaining that physical hardware, and you can significantly speed up your ability to adopt new technologies. Because you're operating in this pay-as-you-go environment, you're free to experiment with new technologies and services very quickly, and you're only paying for what you use. If you pivot and decide that wasn't the right path to go down, or you are changing your direction, you aren't stuck with the long-term investment of procuring hardware, keeping that hardware running, all that comes with running that yourself. The other thing that these providers all offer is, a whole host of different hosted solutions. That means if you want to adopt the new technology, you aren't dealing with the overhead of learning just how to get the thing to work. Going back to the deployment conversation, Kubernetes has become pretty much the default orchestrator for a containerized microservice application architecture. And it's true that not everyone needs Kubernetes to run their containers, but all of these providers have made the barrier to entry so low with their hosted options. They provide the control plane, the core services all out of the box, and they take an ownership of a lot of the maintenance and skills required just to adopt Kubernetes. And when it comes to managing data, they all offer managed databases, services for machine learning and analytics, and reliable, highly available storage for all of that data. Now, it's not to say that moving to the cloud doesn't come with its own challenges. Like the complexity of these interconnected systems can make troubleshooting and governance a bigger challenge, especially as things scale. But if your governance processes degrade, you do risk, introducing bad security practices, opening yourself up to new vulnerabilities. It's true that almost every data breach you've heard about in the last 5 years or so has probably been running in the cloud somewhere. And we see these security gaps most often in organizations early in their cloud adoption journey, where it's just easy to trust what the provider's telling you in terms of, we have automated encryption at rest, encryption in transit, we have secure data centers. But at the end of the day, the cloud is still just running your infrastructure on someone else's machines. So that's a big challenge. The cloud is not always going to be cheaper than just running your own machines, but you're getting a lot from, the value that they're providing of managing all this. So pay as you go, pay as you are using, pay for what you're using, can provide a lot of flexibility, but it can also cause that cost to just balloon out of control if you're not scaling correctly. So we provide a lot of cloud engagement specifically around cost, just because the benefits make it really easy to get hooked on your cloud provider. It also makes it really easy to say, oh, our application isn't performing the way we wanted it to, just throw more hardware at it. You're not waiting around, it's just a click of a button. So understanding those security and cost pitfalls can have a large impact on your cloud experience. So again, going back to the way that we sort of mitigate both of those things is infrastructure as code, or IAC. Using IAC is critical to any platform, because whether you're on-premise or in the cloud, the infrastructure running our applications is the most critical piece to have consistency and maintainability. IAC allows us to define exactly what all of our environments are going to look like, whether it's network policy, security permissions, scaling. We can guarantee that we'll have the exact same configuration in all of our deployments. So the earlier tasks of testing our code via continuous integration or deploying our code would not be reliable if we're tweaking things as they came up. You can picture a scenario where data is supposed to flow from one service to a database or one API to another. And if the network policy is blocking that, it'd be super easy to go into the cloud console and just update our security rule. Now things are working and you move on. But maybe days later, you then release that code to your next environment and suddenly nothing is talking to each other. You're back to troubleshooting what you did the first time to get it to work. If we have all of our infrastructure as code, we have the confidence that there'll be a consistent topology and policy everywhere that we run that. Using tools like Terraform, we can also rely on things like drift detection to help correct these types of behaviors. Drift detection works by comparing what you've defined and declared to be the end state against what the real world state currently is. So that means almost no matter what change we make through manual intervention, the IAC declaration is going to put things back as they were written. So this is one of the most powerful tools to enforcing that security and governance layer as well. A common scenario is, let's say somebody has permission to go into the console, update the security rules, and they open a port for troubleshooting and just forget about it. This could be a huge vulnerability if they're making access to some service public. Running our IAC, we could then detect that change and revert back to our declared, safe state. The other benefit to declaring infrastructure via IAC is we can now automate a lot of that work. So using CI/CD to not just build and deploy code, we can automate the provisioning of our entire infrastructure footprint by changing a handful of configuration values. It doesn't just speed up our delivery, but it also nearly eliminates the human error. We can build in, the benefits of version control to enforce governance and compliance, and all of our infrastructure changes are then going through, an audit, if you will, through our version control to say who did what and why and who approved it. And a best practice here is to codify our organizational policies and standards so we can make it that a new resource is forced to adhere to those standards rather than being overridden by somebody's specific configuration. This is done similar to how objects and classes are built in a traditional programming language by providing modules and templates that can dictate how things are deployed. We create reusable bits of infrastructure code that can be deployed in a foolproof manner while maintaining our governance. One client I spent time with in the healthcare space had previously required this drawn out security review of any infrastructure a team might have needed. By introducing IAC and those modules, we were able to get that sign off one time from the security team by them looking at our code And downstream teams were then free to consume that code without needing to spend their time going through that review. This is all possible because we're able to demonstrate that the only way our teams were provisioning their infrastructure was through that approved IAC. So we're almost through the pillars, but I want to touch on, what happens when everything is up and running. We need a way to make sure that they stay up and running and get alerted to any issues as quickly as possible, so we can be, more proactive in solving those issues or, preempting them before they start to cascade through the rest of our infrastructure or our applications. So observability just refers to the ability to monitor and understand the state of our systems based on the data the system itself is producing. So that could be watching metrics, logs, or different traces as they flow through the system, and they allow us to predict and react to those changes. Beyond just an alert, we can use metrics to dictate scaling policies as well. So going back to using public cloud, because we can scale dynamically, if you're suddenly experiencing predicted or unpredicted load, we can scale our resources up or down based on those metrics. And that scaling policy should be defined in our IAC and helps reduce any overhead costs by leaving things scaled up to our peak availability at all times. So there's a balance here on the alerting piece of creating meaningful and actionable alert prompts. If our thresholds are too low and we're constantly spamming people about resources or some other anomaly in the metrics, it's likely that the alerting system will eventually just be ignored. If it's not frequent enough or our thresholds for engaging are too high, we may miss our service uptime by simply being unaware that there are issues going on. You don't want to be the company or the service provider who finds out production is down because a customer called and told you so. So another way to mitigate alerts being ignored is to integrate into some sort of escalation policy. Many of the hosted solutions that are part of the observability tooling provide that functionality. It could be we just start with a simple Slack or Teams channel message, and if it goes unacknowledged for some period of time, we actually start texting or calling, emailing individuals that are able to investigate and then pull in others as needed. So again, the observability stack doesn't have to just be detecting when things go wrong. It also gives us that improved efficiency on scaling and avoiding that other overhead. So finally, the culmination of all those other pillars, as I said, self-service and development portals. So the reason I've got this on the other end of that bridge from version control is simply to illustrate that these are the pieces that the development teams and the pieces of the platform that should be sort of transparent. And, on the other end from version control, this is the other end of the guardrails. They shouldn't necessarily have to be concerned with, all of those other pieces, all of those other pillars that are providing the path forward in their day-to-day work. The goal of our self-service is to abstract away that complexity and the interconnected nature of all of the rest of that platform and allow the users to deploy changes and access tools without bottlenecks or anyone's manual intervention or asking permission, that sort of thing. A developer portal can act as a central hub for that self-service capability. It gives us an interface where developers can, access predefined services or resources and automation tasks with just a few clicks. And we can tie our observability into that life cycle of their changes as they move through the environment and display that in the portal as well. So this model provides a lot more speed and agility by removing the need to rely on all of those other teams. If a developer has a new service to spin up, they should be able to answer a few simple questions about what team they're a part of, what language or framework will be used, and maybe the name of their new service or application. So from there, we should be able to tie all of the rest of those dependencies together in an automated way. So for example, we may automatically provision a new repository for the code to live in, and that's complete with all that governance and policy around how the code is merged. If we know the language or the framework, We can use a bunch of different templates to generate new CI/CD pipelines and infrastructure to support their work. We could generate dashboards that are ready for all of their metrics and logs to populate to from the observability side, so that before the team even commits a line of code, in a few clicks, the platform is already ready and waiting for them. So again, the goal is to eliminate the need to wait for any manual intervention from anyone else that may have ownership over that. I control the version control system and I go create repositories, or I control the cloud infrastructure and I go create infrastructure for new teams, or I'm on a pipeline team and my job is just to make sure that their pipelines are customized and, built for their specifications. If we have consistent patterns, this is where we take advantage of all of that work and deliver a lot of value to teams upfront. So this user experience is provided by the portal, plays a critical role at improving overall productivity. Like in large organizations, this consistent self-service platform is more or less essential to providing scale. As teams grow, new members can onboard quickly, and we avoid those team-specific startups, and we get people productive right away. So I wanted to quickly switch and do a little bit of a live demo just to highlight some of what this might look like. So I've created.
Can I jump in, Andy, before
Yes.
you get to the live demo, which, by the way, I'd like to applaud the bravery that we have with the live demo on our call. We did have a question come in. Are the frameworks being used to set up these as self-service systems?
Sure. So there are quite a few open source frameworks. Backstage is maybe the most popular, but I don't want people to think that that's the only solution. As we go into the demo, I will show some SaaS services that provide that functionality as well. But it's also, it's not prohibitive to be able to build these things yourself. We are pulling together data sets from different APIs and displaying them in a web UI. So it's not, we've done this for a number of clients where we have existing tooling, we have existing SaaS services providing, maybe we're using Terraform Cloud, maybe we're using Argos DB or something to deploy changes out into an environment. Really what the goal of that self-service is to give visibility into the current state of where everything's at, and then also to just have that sort of library of, every time we create a repository, these are the steps we do. So really, you're just sort of providing a button. In other clients, we've done this through a ticketing system rather than a graphical UI, where we can integrate into something like ServiceNow, and a team goes and says, we're starting up a new app. This is the name of the repository. This is the team we belong to. This is our chargeback ID, so that as we spin up cloud resources, this is who is going to be paying for them. And we're able to say, fill out this form, hit enter, and then that API can then kick off processes in the background. So that automation piece of here's how we create a repository every time, here's all the rules that go with it. It can just be as simple as a ticket system where you've already got sort of that framework or that UI that shows you, here's your options of how to request new things. So it's not necessary to build it yourself, although you could. But I'll also be highlighting a few of our great SaaS solutions as well.
Right. And then we have another question. You are really getting everyone's brain working today. So we had one of our users ask, what would you say to an IT manager that says infrastructure as code is not necessary and just extra work?
Oh, that one hits me deep. I would say, there are a lot of benefits around avoiding the it works on my machine or it works in this environment solution or situation that you end up in. If you are able to guarantee that things are consistent, all of a sudden you open up the doors to maybe our stage environment needs to look more like prod. In a highly regulated environment, that has a lot of impact on data security. But if we're able to say every environment is exactly the same, we don't have differences. Maybe it's, our resources are different, our scaling policies might be different. But we can guarantee that from a network and policy standpoint, everything is just as secure in production or as it is in development. We want to keep things locked down, and having it defined in a declarative way is the best way to do that. Aside from, the drift detection of guaranteeing that it stays that way, I think the upfront investment of getting your development environment written as infrastructure as code gives you a chance to quickly stamp out more environments. In the world of that client that I mentioned providing a SaaS solution, we were able to delineate, in this particular case using AWS, we were able to divide up our customers into their own environments because we had one build module and template that defined what an environment application should look like. We could quickly spin up a new customer in a matter of minutes. We get the notification from a product owner or a sales team, and they're saying, here's the name of customer A. They're going to be paying for this version of the software or this level of the software. This is their licensing information. We could go update a handful of variables, and in 5 to 10 lines of Terraform code, we could have their entire application up and running in 15 to 20 minutes. And most of that time is spent provisioning network infrastructure on the cloud side. That's just how much time it takes to provision the gateways that are needed for communication. So I think, especially at scale, this is where infrastructure as code really shows the benefit and the speed at which it is worth the time investing up front.
Great. I think that helps answer the question, but whoever asked if you wanted to drop a note in there, we can always add some more clarity. Now, I'm wondering personally if I think many of us were aware of kind of what happened with CloudStrike and Microsoft update and taking it down. Is this something that would have helped with that, or at least help mitigate some of the risks?
It's hard to say. I think reading through their initial reports of what went wrong, this was more of a breakdown in process than it was a breakdown in their platform or tooling. The testing scenarios, there's always going to be edge cases. And going back to that observability piece, there could have been better alerting around a slower rollout. There are strategies around how you roll out your changes to make those staggered, or what's sometimes called blue-green, of deploying your new version to a small subset of people, which would have greatly reduced the impact. And ideally, their observability stack would have notified them that, hey, these things aren't coming back online the way we thought they would, which I think it's not necessarily the infrastructure as code or the other processes or governance around it. I think detecting those edge cases early through their observability stack could have really greatly reduced that blast radius, at least in the case of CrowdStrike. So there's always going to be different pieces of the puzzle that may or may not have been predictable. But that's where that observability stack really informs what you do next once things start going wrong.
Makes sense. Well, I think we've answered all of the questions that have come in. I'm going to turn it back over to you for the live demo.
Sure. So this will be just sort of a subset, a simplified version of what's possible in the world of platform. it's just a quick highlight of, what we can do with some of these different tools. So I've spun up this GitLab group for our Improving Talk series. And within this group, I'm able to create my repository structure. I really love that GitLab gives us these directories, essentially, these other subgroups, so that we can group our resources or our repositories. But as we dig in here and just look through this list, I want to highlight sort of a layout that could provide value around organizing your platform itself. So looking at our platform services, a lot of times the security around what images are we using from a Docker perspective, we want to own those images. We don't want to be pulling from the internet somebody's random image that says it has Terraform installed. We can build our own image through its own pipeline to say, this is how we want our Docker container to look. Most modern CI/CD systems today are really operating off of YAML markup that defines a containerized build process. So these pipelines end up, coming out the other end of releasing a specific version of our container. So this is, again, yet another build artifact coming out of what we're trying to, control for security and things, and have it be predictable and versioned, and we know what to expect. So going back to our sort of root of our organization here, this central source idea is a way to provide a centralized location for either pipeline templates. In this case, there's a couple of different cloud infrastructure modules for Terraform. Specifically, this would be operating against AWS, where we're deploying a VPC, which is our virtual network out in the cloud, and then a jump box or a bastion host to be able to access that environment. We're able to codify into here things like network sizing, default security groups, ports that may be open or closed. Again, we're putting all of that into code so that we don't end up having to get multiple sign-offs of saying, I need this port open, I need that port open. We have a way to say what our organization is comfortable with. To pull those things together, this is just an infrastructure repo that goes and is consuming those different modules. And we can see here in the Terraform code that we're going to build our VPC and we're going to build our jump box. Both of these have been versioned so that we know where those are coming from. We know what artifact we're building from. We know that those policies are baked into that version of the module. We're not pulling in new changes that have been introduced because we have this pinned to a very specific reference. And in these 20 lines of code, we could stamp this out 100 times if we needed to for all of our different environments or our different application environments or any of that. So all we would really need to change here is maybe a name of some sort, and we'd be able to do this over and over again in a predictable and consistent way where it would come out the same way every time. So if we were to look at what these pipelines look like, in the case of Terraform, what we want to have happen is we want our plan to show us the difference in what is expected to happen. So again, comparing our state of what exists in the environment against what we want to have happen. So Terraform provides us this ability to look through all of the resources that we've declared and say, here's what we're going to build out in the real world and how your existing infrastructure is going to be impacted. In this case, this plan is showing us that our image that we're deploying for our jump box has changed. This usually means that a new version has been patched and released, and it's telling us this is going to cause this particular resource, our AWS instance, to be replaced. We're going to replace the entire instance and deploy a new one because we need to apply those updates based on what we've defined in the module that says, give me the latest, most secure image every time you deploy this. Going back to our idea of version control and how we can control the mitigation of risk around this if we need to have a way to update this configuration. Maybe we're we're pushing really hard on the idea that our jump box is maybe more like an application server, and our resources aren't, they're not able to keep up with demand, right? So we can go in and say that we want to change our instance type to a larger instance. We can give that a meaningful commit message. We can put that on a new branch so that we can say, that we want to start a new merge request so that we can track these changes through the environment. And at this point, our new merge request would go out for review. It would show our team, what changes are being introduced. And you can see that we've automatically kicked off yet another pipeline that is going to first validate that our Terraform code is correct, and then show us another plan of if we were to merge this change into our code base, what will happen downstream in terms of our infrastructure. So I'm not going to wait for that to actually run through. It does take a few minutes, maybe a minute per stage. But in the interest in time, I will show a previous merge request pipeline and what this looks like. So after we get through our validation and says, yes, your code is syntactically correct, there aren't any errors in your code, we can go look at what our plan is for changing that instance. So in this case, it's still showing us the replacement. This was prior to it. This is a different run based on AMI changes. But this is where that process of versioning and controlling when and where things are getting deployed, having this audit trail of saying, if my teammate goes and approves this, or maybe we can require our approvals to come from a particular management group or a group of individuals, they're able to come in and say like, yep, this looks good. This is especially important, obviously, if we were changing some sort of security policy or something else like that. So this is just sort of a small taste of what it looks like to run things through an automated end-to-end process. We could have this be merged into our code base, apply those changes. We know what's going to happen because we've got all of that other governance in place. Switching over sort of to like how we could drive this from a development portal. This is not an endorsement of this product necessarily, but I really like Port. This is one of those SaaS solutions to sort of plumbing all of your different services together. And I think their demo gives a really good idea of, what this can be used for and all the different ways you can integrate these things. So in this particular case, we've got sort of this landing page that is customized to my role within the company in terms of like work that I'd have waiting for me that I'm going to have to start working on for the day, integrations into Jira, ongoing incidents. We're tying together observability, version control, CI/CD pipelining, release management. All of that is being pulled in here, all into one interface. Jumping over to their catalog, we can see over on the side here that depending on our role within the company, we may have a different interest in what's actually going on. So a VP of engineering, they may actually care more about our metrics around our DevOps response times, how quickly are we pushing code, how much are we changing repos. They may not care about the specifics around what does the pipeline status look like. They want to see metrics around how are these things, operating, and how are our teams operating versus the specific code changes that are going out. And then finally, this self-service portal, I think, is a good highlight of all of that automation we talked about that could go into some sort of self-service option. You could picture this being sort of standalone from those other two pieces if you were just using something like ServiceNow. But if we're a new team coming in and we need to go build out a new service, we can go out here and say that we're building out a new demo service. We're part of the DevOps team because, platform. And we're going to be able to basically say, hey, these are all the different types of projects that we can support on the platform. We have automated templates around CI/CD. Maybe it's scaffolding on your actual repository itself in terms of directory structure, things like that. We can basically say, you know, this is, we can put data retention policy in here. We can put SLA policy in here. There's a lot of different options to build into this. As much as we want to abstract away things, I think being able to answer 6, 7 prompts and then go out and build that, you know, repository, it's really powerful. I didn't have to talk to 3 different teams owning 3 different systems. I can do this by myself. Maybe it goes through a manual approval process, but if we empower developers with the right roles to come out here and start creating these things, this is a really great way to, you know, reduce that friction and overhead and empower people and development teams to own a lot of their own processes. So there's a lot of examples out here. This demo is live that they host 24/7. So I encourage you to go take a look and get ideas for how this could be implemented within your organization. But, you know, this is just sort of trying to highlight what this platform can look like. So I'm going to go back to our presentation here and just kind of wrap up saying, you know, where is the maturity around these things and what does that look like to be mature in these different areas? So this maturity model is taken from HashiCorp. I already told you I'm a Terraform diehard, love HashiCorp. But I really like the way that they've kind of broken this down of adopting platform and allowing tools to development, or allowing development teams to experiment with different tools. It's very ad hoc. It does sometimes lead to various implementations with different teams using different tool sets or cloud providers or different processes, especially in really large organizations where one team could be the size of a small company and they're not necessarily talking to a team on the other side of the org. But most often this results in like cost overruns, security vulnerabilities, some of that duplicated effort and time to value of, you know, just lack of standards. And that's where the next phase comes in of standardizing how these things work. So standardizing your platform and your cloud implementations to define all of these different systems, define the templates, define the patterns and workflows, and start to create that shared service model where different teams can collaborate on different pieces. And we have one way of starting to build those guardrails. And then finally, you get to scaling. So once you've built that guardrail system and you've got your bridge going from that workstation to production, this is where you can start growing that bridge. Maybe it means instead of one cloud provider, you're going multi-cloud or hybrid cloud with an on-premise environment. And at this point, you're able to go organization-wide with sort of a cloud-native platform that you're able to integrate into all of the rest of your business. So this is just sort of something to keep in mind of where do you think you're at? How do you think you might need to be changing your processes? And do you need help getting there? You know, we've consistently seen, you know, there's different ways to engage, but building out a solid platform almost immediately provides value to an organization around all of those other areas that we're touching. So with that, I will leave it for any other questions that have come in. Yeah.
Well, we do have another question that came in. It was during your demo, so I wanted to wait for you to get through it.
Sure.
But somebody on our chat asked, when it comes to observability, what are your thoughts and experience around using native cloud platform tools, the Azure App Insights, Azure Monitoring, et cetera, versus a third-party tool like Datadog, New Relic, something like that?
Yeah, so I think especially going back to that maturity model and scaling out, that vendor lock-in to this is our cloud's native way of consuming logs or consuming metrics. I think that is still fine, even if you say we have one cloud only and that's what we deploy to. But in the case of like multi-cloud or pulling in data from on-prem and different sources of truth, those third-party services offer a lot of flexibility of they're kind of agnostic to where the data is coming in from, and you're able to centralize that. Datadog does a great job of that, New Relic. There's also open source alternatives. Grafana and Prometheus are really huge in the Kubernetes space. But Grafana is a great example of something that you can get up and running, and you can pull in your app insights, you can pull in your logs from Azure, but you also are able to say, here's where our on-prem stuff is living as well, all of that. So it doesn't necessarily have to come from those first-party services. I think bringing in third-party tooling, especially around observability, it can be really powerful. It's similar to the agnosticism of the infrastructure as code tooling, being able to control multiple, Terraform in particular, being able to control lots of different sources. Having your observability centralized, regardless of where it's coming from, is a great way to put that on the third party so that you're able to put everything in one place.
Great. And we have another question that came in as well. What do you think about the concept of vendor lock-in? Is it a big deal or much to do about nothing?
I think probably from my answer around the observability, you can guess that I tend to try to avoid vendor lock-in. I do think it is certainly a real thing. A few, maybe 4 or 5 years ago, we had a lot of healthcare customers operating on AWS. Amazon then decided to go into pharmacy and some of that, and some of those providers felt like they were basically paying their competition to get better by hosting their solutions on their cloud provider. Whether or not that business decision was, exactly correct or perfect or any of that, if they had not used cloud agnostic tooling, it would have been much more difficult to make the decision to say, we're going to pivot and we're going to move things to Microsoft Azure, or we're going to pivot and move things to GCP. I do think it's a very real thing. And that's why I often advocate for, third-party solutions around observability, using tools like Terraform that are cloud agnostic, so that while you will have to rewrite some of your infrastructure definitions, you're not totally starting from scratch. So you're not feeling like there's the sunk cost fallacy of like, we can't move because we are too invested into that one system. That's also true of like running servers on those systems, or using a provider specific technology, such as their particular implementation of maybe ML, AI tooling, any of that. So I think that vendor lock-in is a very real thing, but the degree to which it's going to impact you is really going to depend on the rest of how the platform is structured.
Great. And then I know we're at time, so I just had one final question. How can people get in contact with you if they'd like to continue this conversation further?
Sure. So yes, I appreciate everybody attending today. If you'd like to reach out, you can find me on LinkedIn. I've also included my improving email address here, and I'm happy to talk more, answer more questions, and keep the conversation going.
Wonderful. Well, Andy, thank you so much for taking the time to share your expertise with us today. I know there was a lot of engagement, a lot of great information, and I really appreciate you taking the time out of your schedule to share your knowledge with us. And everybody on the call, thank you so much for joining. We really appreciate you sharing your lunch hour and taking the time to invest in yourself and learn a little bit more. As noted, we do have an entire series running the month of October called Tomorrow Technology Today. So next week on October 15th, we will be hosting Rich McCraw. He will be talking about how to tell if your data platform is actually modern. And of course, you can always find a schedule of our talks on our website at improving.com. Just pop over to thoughts and you'll be able to rewatch talks like this, share this information with anybody who may have missed, and see what we've got coming up. So again, everybody, thank you. Have a wonderful day. Enjoy the fall weather wherever you are, and we'll see you next week.